classroom. Today we are going to learn how to add, subtract, multiply, and divide, and solve inequalities. After you watch this, make sure you bring your work with you to class tomorrow, and also make sure for next week, you're going to have another quiz. Make sure you study. All right, so let's get going. We are going to look at solving inequalities using addition or subtraction. This is really simple. It's just like what we did for solving equations. Nothing has changed. Look at this word problem. It says, which of the following represents your friend's situation? In 3 years, your friend will still not be old enough to vote. If you don't know, the voting age is 18. You have to be at least 18 to vote. So in 3 years, so we have however old you are right now, if we add 3 more years to that, you can say that's plus 3, you will not be old enough to vote. So we know that result has got to be less than 18. So let's look at our choices. X plus 3 is less than 18. Well, that matches perfectly. It's probably the right answer. Let's check the other answer choices, though. X plus 3 is less than or equal to 18? No, because if you're equal to 18, you can vote. So that cannot be the right answer. Again, this is greater than 18. If you're greater than 18, you can vote. That is not the correct answer. And if you're greater than or even equal to 18, you can still vote. So the only choice left is the obvious choice, which is weird news, the correct one. So let's see about how we can go about solving these inequalities. Well, let's take, for example, this one right here. X minus 4 is greater than 5. Just like you would do with an equation, x minus 4 is equal to 5, you would tell me to get x by itself, we would have to add 4 to both sides. We're going to do exactly those same exact steps, but with the inequality symbol. So we still want to get the variable by itself, x. So we need to add 4 to both sides. And when we do that, our result is x is greater than 9. And that is our inequality. And we learned the other day how to graph them. Where's your attention seeker number? Well, 9. 9 saying, here I am, here I am. So let's look at the number line. Draw a circle around the 9. Is it an open circle or a closed circle? It is an open circle because we do not have the or equal to part. So number 9 does not get to go on the fun ride, but it's our boundary, so it's our attention number. So we circle it. Now we have to decide, are the numbers to the right part of the correct solution set, or the numbers to the left? Well, let's look. Try 10. Is 10 greater than 9? It is. So we're going to shade towards the 10. So you shade towards the 10 in the greater positive numbers, and don't forget the shade in the arrowhead. This next example, exactly the same thing we would do with the equations. This time it's with an inequality. We want x by itself, subtract 4 from both sides. And we end up with x is greater than 1. Again, open circle because we don't have the or equal to part. Circle on the 1, shading towards the 4. Another example, here we go. Let's look at this one out here. 15 is greater than or equal to 6 plus x. We want to get x by itself. How do we do that? Subtract 6 from both sides. Leaves us with a 9 is greater than or equal to x. Are you allowed to flip the whole problem around? The answer is yes, but if you do that, make sure your inequality symbol gets flipped with it. Okay, 9 is greater. So if I rewrite it, I need to write x is less than or equal to 9. See how I flipped it here? Because the 9 is still being eaten by the greedy gator. 9 is a greater value. 9 has to remain the greater value. You can't just flip the sign for fun. You have to make sure you rewrite it. So these are both exactly the same inequality. And if x is less than or equal to 9, 9 is our attention seeker. And it's a closed circle because we're including 9. 9 gets to go in the ride. And we're talking about all the numbers that are less than 9. So all these to the left. Shaded in, even the arrowhead, and there we go. Let's try one more with addition, subtraction. So it's the same thing with fractions or decimals or whatever it is. Let's look at this one. 1/3 plus b is greater than 3/4. Well, we want b by itself. Subtract 1/3. Those cancel out. I'm left with b is greater than, subtract 1/3. And now it's back to just 4th grade, 5th grade knowledge. 12 times 3, 9. 12 times 4, 4. 9 minus 4, 5 over 12, 5/12. And you can graph that as well. At least 5 numbers on your number line. 0, we'll call that 5/12. I'll call that 1 whole. negative 5/12, and negative 1. Open circle on 5/12. There it is. Open because it's not greater than or equal to. It's just greater than. Since it's greater than 5/12, shade towards the 1 and the arrowhead because it goes on forever on the number line. Same thing is true with solving inequalities using multiplication or division. Nothing changes except for the fact that now we have multiplication or division. Look at B, for example. 3x is less than or equal to 9. How do we get x by itself? Divide both sides by 3. And I get x is less than or equal to 3. So, right away, I already know I'm looking for a graph that has a closed circle because I have the or equal to part. And my attention number is 3. So I'm looking for a closed circle on 3. Well, A has that, B has that, not C, D, E, F. Nope, so it's either A or B. I want the numbers with the solution set with all the values that are less than or equal to 3. So closed on 3 and less than 3. So towards the 2, 0, negative numbers. Shaded in. So A is the correct answer that matches this question right there. Situation with division. X over 4 is less than 2. Again, x by itself, how do we do that? Multiply by 4. To both sides, we end up with x is less than 8. If we need to graph it, there's 0, we'll call that 4, 8, 12, I'll call that negative 4. X is less than 8, not including 8. 8 doesn't get to go on the ride, so I have an open circle on 8, and all the numbers to the left, less than 8. Shaded in with the arrowheads. This is exactly how you solve it with addition, subtraction, multiplication, or division. What I would like for you to do before you come into class tomorrow is I would like for you to look at these 3 problems, 4, 5, and 6, have those done on a sheet of paper, and bring these with you tomorrow to class. Be ready to share, be ready to go. Come in with any questions you might have. I'll see you then.